So in scientific notation, what we're going to do is take huge numbers, like what is the distance to the sun, okay? It's like 93 million miles. So if we take this number and write it out, we've got a lot of numbers, okay? We can condense this and write it in a shorter version, condensed version, which would be the scientific notation, okay? When we do scientific notation, the decimal always goes after the first number, okay? That's the #1 rule. So we're going to take the number that we have without the zeros, just forget the zeros. So we're going to have just 9.3, because the decimal always has to go after the first number. If the decimal's in the front or back here, it's wrong. Okay, it's not scientific notation. Scientific notation says it always has to go after the first number. Now we're always going to do times 10 to some power. So if you think of this decimal being right here, where is the decimal? First of all, where's the decimal in this number? If there is no decimal, it always is at the end. So if I move that decimal right here, how far is that to the end, where it is in this number? How many spaces do I have to move? 7 places. That's my exponent. Okay? So all scientific notation did was take this huge number and shorten it down. Okay? So it's the same exact thing. If we were to take the 9.3 and multiply it times 10 to the 7th, remember when we multiplied by 10 or 100 or 1,000, we just move it that many places? This says that there are 7 zeros here, so we're going to move it 7 spaces. 1, 2, 3, 4, 5, 6, 7. We have our same number. Okay? So all we did was put it in another format, make it a little bit shorter. What if we have an even huger number than this? Okay? So if we have really, really big numbers, okay, I've seen numbers that have like 20-something digits in it, okay? That's all the way over to here, okay? That's a long number. What if we can condense it down and make it in a simpler, easier to use format? Anybody in science, have you ever heard of Avogadro's number? 6.22 times 10 to the 23rd. It's used for calculating moles and other. My daughter was in chemistry, so I helped her. But this is a huge number. You have to move your decimal 23 places. That's a big number. So this is used for writing huge numbers. It's also used for writing little tiny numbers. What if you have something that is so microscopic that on the head of a pin, several of them will fit before it will fill up the head of the pin? Okay, that's how small they are. You can only see it with a microscope. That's going to be something like 0.00005. Okay, so we can take this number, because there's long ones that go this way as well. Okay, huge or very, very small numbers, and we can take this and put it in scientific notation. The decimal point always goes after the first number. So in this case, we only have the one number, so it would be 5, or you can do 5 point or 5.0. Okay, you can do any of those times, and it's still going to be times 10, whichever way you want to do it. Now in this case, our decimal is right here at the end. Now we're having to move backwards. So how many spaces do we have to move backwards to get up to this one? 1, 2, 3, 4, 5, 6. We moved 6 in the backwards or the negative direction, so our exponent is going to be negative. A negative exponent means a very small number. Positive exponent means it's a bigger number. Okay? Now sometimes the book will ask you to write these numbers in scientific notation. And sometimes they will have them in scientific notation and have you write it as a standard number. Okay? That's just a normal number that we usually write.